Good evening to all. Today I am going to discuss about the topic called stiffness versus torsional rigidity. We all are very much familiar about the term called stiffness, how stiff it is. The stiffness is more. In what way we are telling this term stiffness? Even we are going to take a pen, we have a push and pull type. There is a mechanism that this is due to the mechanism and the property given by stretch and shrink by the spring. That the spring action will take care of and stretch so that the pen will come to outside, and in this it will come into, that is the elastic nature, because stiffness here the elasticity will be coming into a very important parameter. What is elasticity? We know that elasticity is a property of material which will get elongation or shrinking. Okay. And when we apply the load, okay, when we apply the load, it will elongate or it will shrink also. Both will happen. That means simply it is deformed. So deformation occurs when you apply the load in the other material. And if you release the load, immediately it will regain its which is the exponential shape. Okay, that is called elasticity. That is the pure elasticity. But a perfect elasticity materials are not available in the world. There are 90% or 80% of the elasticity is there. But the reverse process or property is called, the property is called the plasticity. Because when you apply the load, it will deform, and it will release the load, it will regain its original shape. It is called elasticity, but it will not regain once if you release the load. That our property is called plasticity. Okay, that is simply I will tell you, this is a temporary deformation in elasticity, temporary deformation in elasticity, permanent deformation in plasticity. Likewise in stiffness, if you stretch it, okay, there are number of springs in there, number of springs, and you are applying the load. Okay, you will apply the load. Here, the diameter of the wire is very small. Here it is somewhat bigger. Is there any difference in stiffness? Have you found out? Yes. Okay. If it is small in size, the wire diameter is small, you can easily apply the load. Small amount of load you can give so that it will deform. But in rigid, okay, the diameter is higher, and take the material property also for strength place. Okay. And even in lorry, some springs are there which will have more amount of rigid, so that if you apply the load, it will not easy to deform. And if you apply the load maximum, give maximum amount of load, so that it will deform to some amount of what you need. Okay. So from this I can tell you, stiffness is equal to load by deflection. Load by deflection. So from this I will tell you that the stiffness refers, this is for deformation or deflection, and this is for the load applied. Here the load is applied to get 1 unit of deformation. How much amount of load is applied? Axial load is applied, because it is uniform, that is longitudinal direction. So the load applied should be axial. So that is axial load. So to produce 1 unit of deflection, whatever the amount of load is applied is called the stiffness. If the amount of, if it is rigid, then if it is stiffness is high means what? You have to apply, even you are going to get 1 unit of deflection, you should apply more amount of load, so that if you apply more amount of load for to produce 1 unit of deflection, the stiffness is higher. So that is the direct proportion of the load. And it is torsional rigidity. So here torsion produces, torsion comes into the picture. Torsion means here torsional rigidity, so T by theta. Torsional rigidity, okay, torsional rigidity is given by T by theta. So here instead of axial load, you are going to apply torque. Okay, you are going to apply a twisting moment called torque. So that it will produce an angular deformation. Angular deformation. If you take a shaft, there will be a angular deformation occurs due to the amount of torque to the applied or given. Here also I will tell you to produce 1 unit of 1 degree of angle, how much amount of torque is required. That is called the torsional rigidity. If the torsional rigidity is higher, the amount of torque when you are applied should be higher to produce for 1 unit of angular deformation. Okay, so both are same, and the thing is the deformation point of view. Here it is axial deformation, in torsional it is angular deformation. And the applied load, here it is axial load, and in torsional rigidity it is angular twisting moment, that is called torque. Okay, so the unit here we should say the stiffness, the unit is meter per meter. Okay, here is unit will be meter per d. Okay, this is Newton meter per d or radius. The same concept. Unit for torsional. Okay, so thank you for watching the video. We will see you in the next class.